That money accumulates based on combinations of principal and interest is a fairly well understood concept, even if the calculations are not. On the other side of the compounding interest calculation is present value. This value is needed to identify how much to save for a target number in the future with either a single deposit or a series of deposits, or how to pay off a loan within a number of months or years. The first of these calculations is called the present value of a single deposit. It answers the question, how much money do I need to deposit today, given a known rate of interest, compounding method, and time period to accumulate a target amount in the future. A calculation like this is always based on a series of assumptions. Among these is the most obvious one, that the mutual fund will achieve the same average rate of return in the future as it has in the past. Second is the assumption that you will reinvest all earnings, dividends, interest and capital gains because to accomplish your goal you need the compounded rate of return. You also need to determine which compounding method is best to use. The advantage of formatting a calculation in a spreadsheet is that all of the variables can be changed and all the outcomes will change accordingly and automatically. Even if you have entered monthly outcomes for 5 years, 60 months, as soon as the variable change, you can also change the variables to keep the exercise realistic. If your mutual fund loses money in the first 3 months, your net fund will be worth less. By depositing additional funds, changing the variable, you can create a revised worksheet. If the fund's performance is unexpectedly positive, you can instantly see how much excess your 5-year plan will create. The excess can be treated as a type of reserve against future cyclical downturns. To calculate the present value of a single deposit, you need only to know what assumptions you will use, the annual average earnings rate, compounding method and desired end result fund. Here is the formula. This formula is not actually as complex as it looks at first glance. The value 1 is divided by a series of familiar calculations. The annual interest rate has to be reduced to the periodic rate, and then the number of periods, normally months, is calculated. For monthly compounding, the annual rate has to be divided by a P of 12, number of periods. For quarterly, the number of periods is 4. The resulting factor is then multiplied by the amount of deposit needed at the end of the period in order to find the value of the single deposit you need today. Let's see an example. You want to accumulate a fund of $8,000 in 5 years. You assume the rate on the investment is 7.5% and you will calculate compounding monthly. How much do you need to place on deposit today? So let's see this example on a spreadsheet. Let's enter the values on a spreadsheet. The final deposit amount in the example is $8,000. The annual interest rate is 7.5% and the term is 60 months. First, we should calculate the periodic interest rate, which in this case is 1 plus the annual interest rate divided by 12 because we use monthly compounding method. If we use quarterly compounding method, we should divide the annual interest rate by 4 here. And this periodic interest rate plus 1 is the same for each month in the period. The compound interest for the first month is the same, but for every other month afterwards, the formula for compound interest is the compound interest from the previous month multiplied by the periodic interest rate plus 1. And here you can see that the formula is exactly the same. Compound interest from previous month multiplied by periodic interest rate plus 1. So here you just have to, when you enter the formula for the second month, you just have to drag this to the end of the period in order to receive the values of compound interest for every month. Afterwards, here is the resulting factor formula, and we put this formula at the end of the period. And the formula is 1 divided by the compound interest for the last month of the period, or here in this case, the month 60. And here is the resulting factor for the whole term, 60 months. Afterwards, in order to find the amount we need to deposit today, the formula is the resulting factor multiplied by the final deposit amount we need in 5 years. And we receive that we have to deposit $5,504.73 US today if in these conditions 7.5% annual interest rate compounded monthly in 60 months if you want to have $8,000 amount. This formula presents a scenario based on a well understood assumption. However, if you need to alter your assumptions, a copy and paste operations is easy to perform. For example, if we want this target amount of $8,000 in 50 months instead of 60. And here we just have to enter the formula 1 divided by the compound interest of amount 50. Okay, and afterwards, let's just enter it here. We should multiply the resulting factor, in this case 0.73233. We should multiply it by the final deposit amount we need in 5 years, and we will receive here the amount needed today. It's 5,859.